All right, so what we're going to do is we're going to go over this test here. This is an old test. So the bullet shot horizontally out of a gun will land at the same time as the bullet case hits the ground. So we've got a bullet that's being shot, and when they say the bullet case, they're talking about the thing that the bullet is in, where the gunpowder is. So what you have is a bullet, and then back here would be the case. So they're saying the bullet's going to go out, and the case are going to fall, and they're going to hit the ground at the same time. Well, the question becomes, what's pulling on them? Well, what's pulling on them is gravity. So in this case, the answer is true, and there is nothing to fix, and the reason why would be gravity pulls on both at the same rate, hence they fall side by side. Sometimes we don't like to think of it that way. We want to say that the bullet has some type of ability to actually fly in the air. It's really just going through the air and falling at the same time. It's going forward, but it's falling the exact same speed that the case is falling. Now, sometimes students want to say, well, the case is actually shot up before it comes down. In this case, we're assuming that the case is simply falling out of the side of the gun. Don't make it more difficult than what it's meant to be. And some of you are going to say, well, that's not how it is in real life, but that's how we're assuming it to be for this problem. In projectile motion, an object is being accelerated in the x direction. Let's go back to this problem right here. This bullet, once it's shot, once it's out here somewhere, again, we've said in class that we don't take into consideration air resistance because it's so infinitesimally small for most projectile motion objects that there is nothing speeding it up. There's not like an engine behind it. Once it comes out of the barrel, the gunpowder is no longer accelerating it, and wind resistance isn't slowing it down. So in the x direction, which means left and right, this would be false. And it's being accelerated in the y direction because what's pulling on it? Gravity. So gravity is an acceleration, so it's going to be accelerated in the y direction. And again, gravity is the only acceleration an object in projectile motion experiences. And that is the very definition then of projectile motion. If it's having any other type of acceleration, then it's not in projectile motion. Okay, so let's go here. Find the missing components of the following triangles. Well, so as I look at this one, if I come out, this is my opposite. So x here is opposite, and the 8 is the hypotenuse. So what trig ratio uses opposite and hypotenuse? Well, that's the sine function. So, well, for some reason we're clear over there. I guess we're just going to work this one out here then. So if I wanted to find that, I would say the sine, and I'm going to say of x, or 29 degrees, is equal to opposite over the hypotenuse. Well, now I know what the hypotenuse is. The hypotenuse in this case is 8. So I'm simply going to take my calculator, and this becomes, or if I solve this, this becomes 8 times the sine of 29 degrees equals the opposite. Well, punch that in my calculator, and I get 8 sine of 29, and I get an angle here of, or a angle, or not an angle measurement, but a side measurement of approximately the opposite, or in this case x, because we said I was using O for opposite, but it's actually x. So I'm going to go back to using x here. X equals 3.0 3.9, and they don't give us any units, so x is equal to 3.9. All right, key thing here is make sure your calculator is in degrees, not radians. All right, so I'm going to go on here to B. It says find angle A. So that means over here they want to find theta. And whenever we've got to find missing angles, we're going to have to use the inverse sine or inverse cosine or inverse tangent function, because we're doing the opposite of finding a side, we're finding the angle. So that's how I always remember it, at least. There might be some other mathematical tricks we could use, not really tricks, but reasons. But for me, it's just easy thinking. The inverse means the opposite, all right? And I'm not finding a side, so I'm going to be using the inverse sign. In this case, this is still my opposite, but this over here is my adjacent. So in this case, opposite and adjacent is tangent. So it's tangent, and this would be to the negative first. That means that little caret, it means inverse. And it's opposite over adjacent. So it's opposite over adjacent is equal to theta. All right, or I'm going to say A in this case because I don't really have a theta symbol here to put in. Angle A. So now I'm going to plug in what we have here. The inverse tangent of opposite being 4 over 12 is equal to my angle. Well, now I just plug it in my calculator. There we go. Calculator is working a little bit differently. Actually using someone else's, so I've got to get used to it here. And I get the angle A is equal to 18.4 degrees. I'll put a little DEG on there for degrees. So that's those two. All right. A football is kicked with a tee or from a tee at 12 meters per second at 72 degrees from the horizontal. Break this velocity up into its x and y velocity components. So now we got a story problem here, but it's this similar to what we did. It's very similar to what we did right here. All right, we found actually this. I have it labeled x, but this would be the y component, and then we're also going to find this x component. So I draw a picture here. It's going 12 meters per second. It's 72 degrees. So they want me to find the the y component and the x component. Well, again, if this is 72 degrees, this over here is the opposite. This down here is the adjacent. And then 12 is my hypotenuse. So I can only solve for one variable at a time, so I've got to pick a side. I've got to use two numbers, two things that are given to me. The y is the opposite. Down here, the adjacent isn't given to me, so I can't use it. The hypotenuse is, so I have opposite hypotenuse. That is the sine function. So similar to up here, I'm going to say the sine of 72 is equal to opposite over hypotenuse. Opposite over hypotenuse. Well, what is the opposite? The opposite is y. And the hypotenuse, in this case, kind of like lowercase y, but I like uppercase y. Hypotenuse is 12. So this becomes then for me 12 sine of 72 is equal to y, which is what we said in class. In class, we had given you these two equations. H cosine of theta equals x. We said h sine of theta equals y. Well, if you look at it, the 12 is my hypotenuse. The sine, theta is the angle at 72, and then we have y. Punch this into my calculator. 12 sine 72. Okay, so this right here gives me 11.4. and that would be in meters per second because they do give us units. Now, the other one would be the cosine of 72 equals the adjacent over the hypotenuse. But in this case, the adjacent is x, and the hypotenuse is still 12. So what does this become then? This becomes 12 cosine 72 equals x. Punch it in your calculator. X equals again, make sure that your calculator is in degrees. And it'd be 3.7 meters per second. All right. In this case, if I can take this and move this up some. Oh well. In this case down here now, we have an apple rolled off a 1 meter tall table. It's got a velocity of 5 meters per second. It's going in the x direction. How far from the table will the apple land? Well, I know that the height, or yi, is 1. It's going to land on the ground, so yf equals 0. Gravity is the acceleration. It's negative 9.8. There is no y velocity, so vi is equal to 0 in the y direction. In the x's, all right, so that's kind of my y's. In the x's over here, I know that the initial velocity is 5 meters per second. We can say that xi is 0, and they want me to find xf. Things that are given to me is I have to know that the acceleration is 0 because it's in the x direction. So we have our two equations, xf equals xi plus vix t plus 1/2 at squared. And then we have, hopefully I get it all in here, yf equals yi plus viy t plus 1/2 gt squared. Well, how far from the table will the apple land? That's my xf. Well, that means that I have both the variable xf and t. So I can't solve for two variables. I'm going to come over here to my y equations and start plugging in what I know. Yf is 0. Yi is 1. There is no velocity in the y direction where I have that. There is no. So that means this right here all goes away. That's all 0. And 1/2 g is 1/2 negative 9.8 or negative 4.9, so plus negative 4.9 t squared. T equals, if I subtract 1, divide by 4.9, so I get negative 1 divided by negative 4.9, and then I'm going to square root that, so this time is going to be very small. So time, in this case, time is 0.44 seconds. So now I'm going to plug this time and go over to my x equation to find how far away will the apple land. Well, xf is what I want to know. Vi, we say, is 0, so that's going to go away. There is no acceleration, so that's going to go away. And all I'm left with then is the initial x velocity, which is 5, times the time of 0.44 seconds. And we're going to get an answer. I'm going to round it to the nearest tenth of 2.2 meters. Hope that was helpful for you. All right, down here. Shot put with a mass of 10 kilograms and a bowling ball with a mass of 18 kilograms are placed on a table. The balls are simultaneously rolled along the table and have an x initial velocity of 1.5 meters per second. Both are going to land at the same time, and they're going to land right beside each other as well. Why? So I'm telling you they're going to land beside each other, and I'm telling you they're going to land at the exact same time. You have to tell me why. So in this, you've got a couple reasons. First of all, you have to tell me why land side by side, you're going to have to talk about their velocities being the same, acceleration in x direction. If you don't talk about both of those, you have not fully explained why they're going to land side by side, why one doesn't let go farther than the other. Then you have to say why land at same time. Well, velocities in y direction. Being the same. If you don't talk about that, all right, if one it comes off the table and it's going faster, one's going up and the other one's going down, then they're not going to land at the same time, because one's going to be going up while the other one's going down, so the one going down would have a head start. And then the other thing we need to talk about then is the acceleration in the y direction. Being the same for both of those. If you don't address the fact that the acceleration for both of those in the y direction is the same, then one's being accelerated downwards faster than what the other one is. So you need to go through there and tell me why. You've got 4 things here, so I'd find it hard for you to be able to answer this in less than 4 sentences. Hey, I hope that was beneficial. Catch you on the flip side.